Let's look at another centroid problem. Find the centroid of the area shown, the shaded area. Again, this one, y bar, which is distance of the centroid to x-axis. Let's say this is the centroid. This will be y bar, and then x bar, or if you want to use capital X bar, will be the distance to y axis. Remember, these are opposite of each other, so this will be x bar. So the problem is asking find the location of centroid, location of this point. First thing I like to do is find this k based on a and h. You might have a problem very similar to this, that h and a are numbers and given values to you. I think it's better to do it this way, parametric, and then you can just substitute any number you want. So let's look at it quick. When x equal a, this point, y, well, we don't know what y it is, or y is it. So let's see. When x is equal to a, so this point, then we know y is h. So let's replace or substitute these into y equal kx. So h equal k 2a. Let me write it here better. H equal k 2a squared. There we go. As a result, k will be h over 4a squared. All right. So for these problems, we always draw a little element of area. Okay, so I'm going to take a little element of area, a little sliver, a little rectangle here, and the integration is putting infinite number of these rectangles next to each other. Add them all up and see what you get, and that will be your area. So this is very thin, and it's d x, and then the height of it is just y. So my y bar, this is just centroid equation, is y tilde, or some books notes it as y bar, dA over integral of dA, which is total area. X bar is x tilde dA integral of dA. I'll talk about what each of these mean. Y tilde is distance of centroid of that little element to, this is y tilde, so it's to x-axis. Centroid of this element, this here, it's a rectangle, so it's going to be the center of it. This is y tilde. And then distance of centroid of it to y-axis is going to be my x tilde, which in this case is just x. In this case is half of y2 is my y tilde. So it's y over 2 if I replace the y with the equations I have, is h over 8a squared x2. K I calculated here, and that's my function. X tilde is the distance, as I mentioned, of centroid of dA to y axis, which in this case is just x. And then dA is that differential area, so I have dx multiplied by y, so it's y dx. Let's plug y in here right away. So it is h 4a squared x2 dx. All right, So I have these three. All I have to do is plug them into the integral and do the integration. Let's do y. Let's do y tilde dA. If I replace it, it's going to be h over 8 a squared x2. That's my y tilde, and my dA is h over 4 a squared x2 dx. Looking at limits, I have dx here. So limits of my integral are going to be x1 to x2. My area starts from a, goes to 2a, so a to 2a. If you do the integration, you will get h2, and these are numbers, they can all come out, 32a4 a to 2a, and then all I have left is these two, x4 dx. All right, very manageable. So h2 32a4 x5 over 5 going from a to 2a. If you plug a and 2a on here, you should get 31 over 160 a h2. Let's do x tilde dA. That's the next one I want. X tilde was just x, and dA was h for a squared x2 dx. I have dx, so bounds of my integral going to be x again. x1 goes from a to 2a, same as before. This will result in h over 4a2 a to 2a x3 dx. Again, very manageable. So this will be h 4a squared x4 over 4 a 2a. If you do, oh sorry, this is not integral, just from a to 2a. If you plug a in there, you get 1516 ha squared. And lastly, what I need to do is integral of dA, which is going to be h for a squared x2 dx. Again, when I have dx, bounds of integral are from x, which is a to 2a in this case. h for a squared, let's bring it out of integral, a to a x2 dx. Again, not too difficult. 4a squared x3 over 3 going from a to 2a, and that will result in 7 over 12. I keep the numbers like this, so when you're doing the math, you can kind of follow the math, and if you make a mistake, you know where you've made a mistake. All right, so let's just plug them back into the equation. Y bar was y tilde dA over integral of dA. The numbers we have calculated, y tilde dA integral was 31 over 160 a h squared over dA was 7 over 12 ah. So this will result in y bar being 0.332h. And then x bar, x tilde dA over integral of dA. If I plug what I calculated on the previous slide here, I will have 15/16 h a squared over 7/12 a h, or ha, and this will result in 1.61 a. Thank you very much.